Alright, today we're going to do a sample calculation with molarity and involving with dilutions. You want to say hi?
Hi.
He's going to help out with the molarity and dilution question. Alright, when we're looking at solutions and concentrations, there are four different ways to express your concentration. Concentration is how strong your solution is. The main way we're going to look at is molarity. Molarity is with a capital M. To find your molarity, you do the moles of your solute divided by the liters. That's the volume of your whole solution. A few other ways to look at it is based on mass percent. Mass percent is just the mass of your solute, again divided by the mass of your solution, and times it by 100 since a percent means out of 100. Molality, that's with an L instead of molarity, it's still moles of solute, but instead of liters of solution, we're going to do the mass, the kilograms, and notice just the solvent, not the solution in that one. Finally, the last one is the mole fraction. That's just comparing the part of the whole, the moles of your solute, to the total moles of your solution. So here's going to be a straightforward example of molarity. Again, molarity, capital M, is your moles of your solute divided by the liters of solution. So let's say I have a beaker here, and there's a bunch of water in the beaker, and I'm going to add some Kool-Aid to the beaker. Let's say that I have 3 moles of Kool-Aid when I actually convert my grams to moles, and I put it in a 1 liter bottle of water. To find the molarity, all you do is divide that out. 3 divided by 1 is obviously 3, and then just write capital M for your molarity. Capital M is your unit for molarity. Okay, here's a more detailed example of molarity. Let's say I have 0.435 grams of KMnO4, that's potassium permanganate. Don't get that on your skin, it's hard to get out. Let's say you dissolve that in enough water to give 250 milliliters of your solution. What is the molarity of potassium permanganate? Here's a pictorial example of what's actually happening. So, in order to figure out the molarity, you're going to have to figure out the mass of your potassium permanganate, so we could take a scale and weigh that. You want to put it in this bulb test tube beaker. I forgot the exact name for it, but it actually is measured to exactly 1 mole. So what you do is once you calculate the amount of potassium permanganate, you put it inside the chamber, you add water to the chamber until it hits the line that's, can't see it on the picture, but that top blue line right here, that is exactly 1 liter of solution. So if you're adding your potassium permanganate in first, then you're adding in your water, you'll have exactly 1 liter. So it's a very accurate way of measuring it. In order to solve the question, you want to convert your mass to moles before you do anything else. So if I have 0.435 grams of potassium permanganate, I'm going to find the molar mass. 1 mole is equal to 158.0 grams. You would divide those numbers to get 0.00275 moles. And once you have your moles, you're just going to divide it by the liters. Actually, they give you the molarity in this one. Your molarity is 0.25 liters. That's equal to 0.00275 moles times 0.011 liters. And then you just do your calculations, and then you get 0.25 liters of your solution. Another example involving molarity is with dilutions. To dilute something, or when a solution is diluted, your solvent or water will be added to lower the concentration to make it less strong. When I'm buying chemicals for the chemical lab area, I usually want to buy very high molarities of my solutions and then dilute them afterwards to find the right concentration and not use up too much. Your amount of solute will remain constant before and after. Essentially, your moles before equals your moles after when we're looking at your solute. Here's your main equation for dilutions. It's the molarity times the first volume equals the molarity times the second volume. So example over here, it says a bottle of 0.5 molar standard sucrose, that's table sugar, is in a lab. Give instructions to the assistant on how to use the stock solution to prepare 250 milliliters of 0.438 molar sucrose. Okay, so we're going to start with 0.5 molar, that'll be our M1. We have to figure out how to use that solution. We don't know how much volume to start with, so our V1 is our unknown. We want to prepare 250 milliliters of 0.348. Our V2, let's convert the 250 milliliters to liters. So you're going to have to move the decimal point here to 0.25. Right there. And our 0.348 is our new molarity. What you can do is solve the right side of the equation. You get 0.087. That equals 0.5 times V1. To get rid of the V1, just divide by the 0.5. Your answer is 0.174. And that'll be liters, because remember our V2 is in liters. That's how much water of the standard stock solution we want to start with. So if we look at the picture on the right, we have our concentrated sucrose right here. We're going to add 0.174 liters of the concentrated and then add enough water to it to get to the 250 milliliters. Alright, so that's a generic example of how to do molarity and dilutions. Here's Nathan, he was our helpful assistant figuring out how to do the calculations. If you have any other comments or questions, leave a comment down below on this YouTube video.